Hello, this is Hydra, and today I'll be explaining what quadratic equation looks like. This topic is usually taught in high school, a simple algebra, but I won't just show all the basics. I will show as much as methods as possible, plus some extra, showing that what I know of this topic. Please be advised, I'm not an actual teacher, I'm just sharing what I learned. So a quadratic equation is usually expressed in y equals ax squared plus bx plus c. This can be imagined as a name of a parabolic line on a graph. You will be asked to find the roots of an equation. Roots are the point where the parabolic line touches the x-axis of a graph. There can be none, there can be one or two roots of an equation. There are three main ways to solve the equation, which are factoring, completing the square, and of course using the formula. So let's discuss factoring first. So what you're doing in factoring is basically you split the equation into two brackets, sort of like a magic trick. Like so, for ax squared plus bx plus c into x plus p, s plus q, and p plus q equals to b, and p times q equals to c. I know it looks intimidating, but don't worry, I will show the details of it. To show you, here's a few examples. I'll show you 4 scenarios of what will happen. If both b and c are positive, b is negative, c is negative, or both b and c are negative. As you can see here, when you're factoring, you split it into two brackets, and then those two brackets have to be sum of 5 and sum of 6. As you see at the bottom here, it is guesswork to find the number what it is. So here, the first try, I take it 1 times 6, and 1 plus 6 equal to 7. But that doesn't work. So let's try it again. This time, you're 2 times 3. 2 times 3 equals to 6. Okay, but how about 2 plus 3 equals to 5? That worked. So we can put in 2 plus 5 into the brackets and then get the answer of factoring. At the second column here, you can see that b is negative. When b is negative, the sum of it has to be negative. So both p and q have to be negative. So when they combine together, you get a negative number. So here at the bottom, as you see, I try using negative 1 times negative 8 equals to positive 8. As you can see, negative 1 minus 8 equals to negative 9. So that doesn't work. So I have to try again. So negative 2 times negative 4 equals to 8. That's possible. How about negative 2 minus 4? That equals to negative 6. It worked. So I can put it down as the number. As you can see at the third column here, c is negative. So you have to make sure one of them should be negative because what they times together has to be a negative. But the sum of the product has to be positive, so you have to watch out where the bigger number is. So here at the bottom, as you can see, I try negative 1 times 8 equals to negative 8. But negative 1 plus 8 equals to 7. Doesn't work. How about negative 8 times 1 equals to negative 8? Negative 8 plus 1 equals to negative 7. Doesn't work. How about negative 4 times 2 equals to negative 8? But the sum of the product is negative 2. Doesn't work. So how about we flip it? 4 times negative 2 equals to negative 8. How about negative 2 plus 4 equals to 2? Now it worked. We got the number, so we can put it to the bracket. So here at the fourth column, both b and c are negative. So here you have to pay attention that the negative number is the bigger one. Negative 1 times 12 equals to negative 12. Negative plus 12 equals to 11. Doesn't work. Negative 2 times 6 equals to negative 12. Now sum of together equals to 4. Doesn't work. Now we try again. Negative 3 times 4 equals to 12. Okay. How about we sum it together? 1. Doesn't work. How about 3 times negative 4 equals to negative 12? 3 minus 4 equals to negative 1. That worked. So we put in the numbers. Normally it's guesswork to find the numbers of p and q. It usually works, but it has its limits. So to take out the guesswork, there's a method that I learned from Jensen Math, where I put the video down below in the description. Basically, you start working on b plus q first. You split the value of b in half and then add a constant to it, which I will call it z here. Here's the example. Let's use x squared minus 6x plus 8. We know that p plus q equals to negative 6 and p times q equals to 8. Let's substitute in the method that I just told you. So here p is negative 3 plus z and q is negative 3 minus z equals to negative 6. And then we can substitute them both into p times q equals to 8. Negative 3 plus z times negative 3 minus z equals to 8. And then we can do the basic math here. We can always get this simple quadratic. From here, we can work out the number equals to 1. Then we can substitute in back into here. As we know that p equals to minus 3 plus z. And then we can work out the number equals to negative 2. We can do the same to q. And then we can get the number p and q. Then we can put that number into the bracket. And then you get your roots. So here, the next method is completing the square. The method is slightly unorthodox, but it works. I will explain how completing the square is derived, but let's focus on the method for now. Let's set an equation of x squared plus 6x minus 7. Your first step is to move c to the opposite side, so it becomes x squared plus 6x equals to 7. From here, you add in something to complete the square, and that something is b over 2 bracket squared. So here it is 6 over 2 squared equals to 9. You have to add it into both sides to balance the equation. So it becomes x squared plus 6x plus 9 equals to 7 plus 9. Now you can factor the left side. What I noticed is that you just simply have to divide b in half and take the x out. So it becomes x plus 3 squared equals to 16. From here on, it's just basic math. I know this seems the extra step compared to factoring, but I like this method because it removes the guesswork from factoring, plus completing the square makes sense in a way, which I will explain later in the video. So the third method is to just throw everything into the formula. So the formula is minus b plus minus square root of b squared minus 4ac over 2a. Just throwing the right numbers and it off to the races is the most foolproof, simple solution to do. If you just want the answers, this is the way. Let's say 4x squared plus 7x minus 14 equals to 0. So here, a is equal to 4, b is equal to 7, and c is negative 14. You just throw in the right numbers, and then you can calculate the rest. Now let's discuss some extra scenario that you might come across. Like what if the value of a isn't 1? Well, you can use the formula like a normal person, but you can still factor it. Here's 3 methods to do. Number 1 is to check whether the equation can be simplified into a equals to 1. Let's say 2x squared plus 6x minus 8 equals to 0. So here you can simply divide it by 2 and then you can factor it as normal. Method number 2 is to use Jensen math method. What we will show is a cleaner example, but I will show when the method gets dirty. Let's say 3x squared minus 4x minus 9 equals to 0. So here we factor out the 3 when we got x squared minus 4 over 3x minus 3 equals to 0. Here I will use n plus n equals to negative 4 over 3. M times n equals to negative 3. And then we can substitute in the method that I just told you, and we can do this whole calculation over here. As you can see, the methods get dirty because of the fraction. Once you have the fraction in the method, it gets more and more complicated as it goes. But at the end, I still get the answer. But if you use the formula, it will get much easier. Well, method number 3 is a more traditional method called grouping method. So here, let's say 6x squared minus x minus 15 equals to 0. So here you have to do a times c first. Here is negative 90. Now you have to find what factor works to split up b, which is also the factor of a times c. So as you can see, I try to use negative 9 times 10 equals to negative 90, okay? How about negative 9 plus 10 equals to 1? That is not b, so it doesn't work. But now let's try 9 times negative 10 equals to same, negative 90. But when we do 9 minus 10 equals to negative 1, that works. So we can put it in and substitute equal to 1. So we can use that as what to split b. So here, when we split b equals to plus 9x minus 10x. So we do that, we can get 6x squared plus 9x minus 10x minus 15 equals to 0. So we first split the equation into left and right and then factor each side. As you can see, when you factor the left and right, the value of the bracket is the same. So we can factor both out, but you factor the value outside of the bracket into the other side. So here, when we factor again from the bracket and outside of the bracket, we get 3x minus 5, 2x plus 3. And then you can find out what the value of x is. As you can see, the method works, but it requires specific condition. So if you're unsure, just use the formula. Now I will attempt to explain how quadratic formula come from. To warn you again, I'm not a math expert, so the explanation won't be perfect. but it will help you understand how complete the square works. To start, let's turn the equation into a form that can be used in the complete the square method, which are a equals to 1 and move c to the opposite side. From here, we can imagine the value of the formula as squares. As you can see on the top right side, this is x squared, this is b over a times x, and then c over a is the area of a square. And you can assume the square and the rectangle on the left is equal in area with the square on the right. Now we want both sides to have the same sizes of square. First, we split the rectangle in half and then stick it to the two sides of the square on the left side. You see a square is missing to make it a big square. As you can see, it's represented by the green color on the right side. This is where the term complete the square comes in. You add in a square yourself to make it a big square. But you also need to add in the missing area on the right too, as a form of sliver of rectangle. And on the left here is simply how I derived the formula. If you want, you can pause and simply read what I've done. So here, let's recap of what we learned. So here we have three methods to find the roots of a quadratic equation. We have factoring, we have completing the square, and also we can use the formula. That's it. That's all. Thank you for watching and see you next time.